Hi friends, welcome to our channel. In this video, we are going to discuss the most important points in DC machines. I think this video will be very much useful those who are going to write any competitive exams. These are the very basic and important, most important points. The first point is iron losses are considered to be the constant losses. It depends upon voltage and frequency. The copper loss in rotating machine are variable losses. The brush contact losses in a DC machine is directly proportional to the current. The brush contact losses in a DC machine is directly proportional to the current. Out of electrical, mechanical and magnetic losses, the losses which is minimum is obviously its mechanical loss. The hysteresis motor are mainly used in tape recorders because of its extremely steady state torque. Out of different methods available for testing of DC motors, Swimpen's test and Hopkinson's test are commonly used in practice on shunt motors. Swimpen's test and brake test, or if you see the Swimpen's test, it's indirect method of testing and brake test is the direct method of testing. If a field current is decreased in shunt DC motor, the speed of the motor will get decreased. Both are inversely proportional. If the field current is decreases, the speed of the shunt motor will get increases. The Ward-Leonard system, the lower limit of the speed imposed by residual magnetism of the generator. Ward-Leonard control is basically a armature voltage control method. For very sensitive and wide speed control, the preferable control method is Ward-Leonard control. Eddy current loss will depends on frequency, flux density and thickness. Hysteresis loss will depends on frequency. It's a very important question. Thin laminations are used in machine in order to reduce the eddy current losses. Hysteresis loop represents the area of hysteresis loss. Swimpen's test can be preferred at only no load condition. While performing Swimpen's test, the iron losses are assumed to be constant. The speed in DC machines can be measured by using tachometer. While carrying out brake test, if the belt snaps, then the motor will rotate at increased speed but in forward direction. While performing retardation test, the machine whose test is to be taken is run at a speed in which slightly greater than its rated speed. The rotational or stray losses includes iron loss, copper loss, friction loss and windage loss. It's important question. The rotational stray losses includes iron loss, copper loss, friction losses and windage losses. The rotational losses in DC machine is equal to the rate of change of kinetic energy. The rotational losses in DC machine is equal to the rate of change of kinetic energy. The regenerative test, the supply is given to the rotor to account for losses. The back-to-back test is best suited for large machines. This is also most important point. The back-to-back test is best suitable for large machines. For performing Hopkinson's test, two identical machines are required which are mechanically coupled. The iron losses in two machines cannot be separated. We cannot separate. The test which can be performed on the DC series motor is field test. To perform field test on DC machines, two motors are required. The motor used are series motors. The difference between field test and regenerative test is that in field test generator output is fed back to the motor, while in regenerative test the generator output is fed back to the motor. In field test the generator output is not fed back to the motor, but in regenerative test the generator output is fed back to the motor. The most common method to check for shortest winding is to perform drop test. To have an induced EMF in DC generator, there should be relative motion between the conductors and flux. The plane of rotation and the plane of flux should not be parallel to each other. To have the DC voltage, a device is used a DC generator to convert alternating EMF into unidirectional EMF. This device is also called as commutator. The commutator also called it as a rectifier. The next one, yoke in DC machine serves the outermost cover. For magnetic flux, it provides a low reluctance path. Brushes in DC machines are made up of carbon. The EMF induced in the DC generator armature winding is AC. If A is the number of parallel paths and P is the number of poles, then the number of parallel path in wave winding and lap windings are, if you consider the lap winding, A is equal to P, and if you are going for wave winding, A value must be 2. In a DC machine, the current rating and voltage rating of wave winding is, if you consider the DC machine, the current rating is low and the voltage rating of wave winding is high. Next one, in DC generators, brushes are used for collecting of currents without any sparking. That's why we are going for the brushes. That is the main function of the brushes. For the construction of armature of a DC machine, the best suitable material is silicon steel. In a DC machine, the form of armature reaction MMF is triangular. In a DC machine, the eddy current losses mainly occurs in armature. This is also important. In a DC machine, the form of armature reaction MMF is triangular. In a DC machine, the eddy current losses mainly occurs in armature. The conductors which will cause distortion in the main field flux of DC machine is cross magnetizing armature conductors. If brush shift angle is given in electrical degree, then for converting it into mechanical degree by using the relation, it is nothing but 2 into theta electrical divided by P. For neutralizing the demagnetizing effect of armature reaction, an extra number of windings turns are provided on each pole. To calculate the number of extra turns per pole, the equation is used. This is the equation A TD divided by I into leakage coefficient. Due to the effect of armature reaction in DC machine, the value generated voltage decreases and flux per pole decreases. Both get decreases due to the effect of armature reaction. The DC machine, the value of generated voltage will get decrease, as well as the flux per pole also will get decreases. The armature reaction in DC machine causes distortion in the main field flux. This effect of armature reaction can be reduced by increasing the length of air gap. If you increase the air gap, definitely the effect of armature reaction will be reduced. Two 4-pole DC machine of identical armature, one with wave winding and other with lap winding or wound. Then wave wound machine will have more generator voltage. The armature in DC machines are always placed on rotor, otherwise commutation will not be possible. In armature in DC machines are always placed on rotor, otherwise commutation will not be possible. In DC machine, the commutator provides it's a full wave rectification. The compensating windings are used to neutralize the armature reaction in DC machines. These windings are connected in series with armature. This is already asked in some other question, that is, I think, Bell exam. The compensating windings are used to neutralize the armature reaction in DC machines. These windings are connected in series with the armature. The armature reaction effect in DC machines can be completely neutralized by using both compensating windings and interpoles. In DC machines, the equalizer connections are provided only in lap winding. The compensator is possible only in lap windings. The generating action and motoring action in DC motor is determined by, for a generating action, we have to use the Fleming right hand rule. For motoring action, we need to use the Fleming left hand rule. Next point, as the load on DC motor increases, the current drawn by the motor will get increase. The load on the DC motor increases, the current drawn by the motor is also getting increases. Both are directly proportional to each other. If the back EMF of a DC motor is doubled, the flux is halved, keeping other parameters constant, then its speed will become 4 times of the original speed. That is nothing but we already know Eg is equal to pi Zn by 60 into P by A. Into P by A. Here they are given Eg is twice the value. 2 is equal to pi Zn by 60. The pi value will be half of the value into P by A. They said all the parameters are constant. If you take all the things and take only the n value, so n value will become as, this 2 will be multiplied 2. So 4 into all the things will come as it is. So what is the answer? It is a 4 times of the original speed. Next one. Keeping the field excitation constant, the constant of proportionality between back EMF and armature speed of DC motor is same as that of proportionality constant between developed torque and armature current. The next one, in DC shunt motor is also called it as constant flux motor. Constant flux motor is nothing but DC shunt motor. The torque developed in DC shunt motor is directly proportional to the armature current. The torque developed in DC shunt motor is directly proportional to the armature conductor current. DC shunt motors are commonly used in lathe machines. DC shunt motors are commonly used in lathe machines. The speed of DC series motor is inversely proportional to the armature current and square root of the torque developed. The starting torque developed in DC series motor is high and DC shunt motor is moderate. In starting torque development in DC series motor is high and in DC shunt motor is moderate. The speed armature current characteristics of a DC series motor is a rectangle hyperbola. This is the important question they asked in gate examination. The speed armature current characteristics of a DC series motor is a rectangular hyperbola. Next one, the DC series motor is started with very light load or no load. Then it will run at a dangerously high speed which may damage the motor mechanically. A long shunt compound motor and short shunt compound motor can be either cumulative or differential. If you see the types of the DC motor, especially in the long shunt and short shunt, again it can be classified into cumulative as well as the differential type. Electric traction, which type of motor is generally used? That is nothing but series motor. A series wound motor, also called it as universal motors, because it will run equally while using either an AC or DC voltage source, AC or DC voltage source. In the flux control method for controlling of speed of DC shunt motor, the speed control is not possible. It's not possible below normal rated speed. In the flux control method for controlling the speed in DC shunt motor, the speed control is not possible below normal rated speed. Which method is suitable for the speed control below and above? Below and above the normal rated speed of a DC shunt motor is voltage control method. In armature voltage control method or rheostatic control method for speed control in DC shunt motor, a variable resistance is added in series with the armature. Speed of DC shunt motors are controlled by flux method. Speed of DC shunt motors are controlled by flux control method, rheostatic control method, voltage control method. The speed can be controlled by in three ways: flux control method, rheostatic control method, and voltage control method. If resistance is added in series with the field winding of DC shunt motor, then its speed increases and torque decreases. Speed increases and torque will get decreases. Ward-Leonard system is used for wide range of speed control and very sensitive speed control. This is already asked in gate examination, so it's important question. For frequent starting, stopping and reversals, which motor is commonly used? Ward-Leonard system. Ward-Leonard control is basically a dash control method. It's a armature voltage control method. In Ward-Leonard system, the lower limit of the speed imposed by a residual magnetism of the generator, which stator does not provide high speed protection to the DC shunt motor. It's a 4-point starter, in which starter does not provide high speed protection to the DC shunt motor. It's 4-point starter. For the protection of DC series motor, which starter is commonly used? The answer is 2-point starter. The basic difference between the 3-point starter and 4-point starter is no volt coil is connected in series with the field winding in 3-point starter, while connected independently across the supply in 4-point starter. That is the main difference. The speed of permanent magnet DC motor cannot be controlled by flux control method because it depends upon the coils. So in permanent magnet DC motor, the coil will not be present. The permanent DC motor are extensively used in automobile, heaters, air conditioners. In the biomedical instruments like artificial heart pumps, the commonly used motor is brushless DC motor. The next one, the machine operating as motor may go to regenerative braking mode if its speed becomes sufficiently high to make back EMF greater than supply voltage. A machine operating as motor may go into regenerative braking mode if its speed becomes sufficiently high to make back EMF greater than supply voltage. The noise resulting from vibrations of lamination set by magnetic forces is termed as hum. With increase in temperature, the speed of series and shunt motor will decrease and increase. With increase in temperature, the speed of series motor is decreases and shunt motor will get increases. The number of windings on the field of permanent magnet DC motor is absent. There is no winding. That's why the field winding, number of windings will be absent in the permanent magnet DC motor.